In today's class, we have to discuss about the refraction of light, like reflection, dispersion. Also, refraction is a property of light. So first, we have to draw the diagram to explain the refraction of light. Let x dash is the interface which separates the two medium. That this is medium 1 and this is medium 2. X dash that separates the two medium, and N O N dash that is the normal, and here one ray that is incident at O. This is AO, that is known as the incident ray. That's why this angle is known as the angle of incidence. And if you consider medium 2 is absence, that means in the absence of medium 2, you find this will be the path of the ray. But here another medium is present. That means you find due to presence of another medium, you find the incident ray will change its path when it enters into the another medium. So this will be the refracted ray OV, and this angle is known as the angle of refraction. That means here you find in refraction the ray of light that changes path and velocity both when it travels from one medium to the other medium. That's why you can write the definition of refraction of light. Write down, it is the property of light by virtue of which the ray of light will change both its path and velocity when it travels from one medium to the other medium. So this is the definition of refraction of light. Once again, the ray of light means the incident ray will change its path and velocity when it travels from one medium to the other medium. That's all about the refraction of light. Then in refraction of light, you find two laws are there. So now the first law of refraction, so that is laws of refraction. you find there are two law of refraction. So first law of refraction. The first law of refraction is, in the diagram you can see the incident ray, you can write AO incident ray and OB refracted ray, and you can say the incident ray, the refracted ray and the normal, N and dash is the normal, all lie in a single plane or in one plane. So you can write the first law of refraction, that is the incident ray, the refracted ray and the normal at the point of incidence lies in one plane. Here the incident ray, the refracted ray and the normal at the point of incidence all will lie in a single plane. So this is the first law of refraction, and here there is another law of refraction, and the second law of refraction, that is, if you take the sine of angle of incidence to the sine of angle of refraction, you find it will be a constant. That means you can write the ratio of sine I divided by sine R, that is a constant, and that constant is known as the refractive index. You can say here the ray of light is traveling from medium 1 to medium 2, so it will be mu to 1. That means refractive index of medium 2 with respect to medium 1. And again, this law is also known as Snell's law. Of refraction. You have to remember the second law of refraction, that is sine I divided by sine R, that is constant, or refractive index of medium 2 with respect to medium 1, that is known as the Snell's law of refraction, where mu to 1, that is known as refractive index of medium 2 with respect to medium 1, that is mu to 1, refractive index of medium 2 with respect to medium 1, and that is mu 2 divided by mu 1. That means refractive index of medium 2 with respect to medium 1. So there is a term refractive index here. So next we have to discuss what is refractive index and the formula of refractive index. First you have to write this. Write down. Complete. So next we have to discuss the refractive index. That is denoted by mu. Refractive index means you have to take the ratio of speed of light in air to the speed of light in that medium. That means refractive index mu, that is speed of light in air to the speed of light in the medium. Medium means if you have to find out the refractive index of water, that means you have to take the ratio of speed of light in air to the speed of light in water, which will give you the refractive index of water. So the formula is mu is equals to C divided by V. You have to remember this formula of refractive index mu. And next, when the ray of light travels from one medium to another medium, you have to remember two things. First one is there are two different medium. That means if you take one medium is denser, another medium is rarer. So the first case, medium 1 is rarer and medium 2 denser. That means the ray of light have to travel from a rarer medium to a denser medium. Then what happened to the refracted ray? For that case, the refracted ray will bend towards the normal. Here, if the ray travel from a rarer to a denser medium, for that case the refracted ray will bend towards the normal. That means if there are two medium present, this is the intercept which separates the two medium, and medium 1 is rarer and medium 2 is denser, and this is the normal. For that case, if this will be the incident ray, this will be the angle of incidence, and here the refracted ray will bend towards the normal. That means it will bend towards the normal. That means this will be the direction of refracted ray. Here the refracted ray will bend towards the normal. You have to remember. And another case, if medium 1 is denser and medium 2 is rarer. That means the ray of light have to travel from a denser medium to a rarer medium. For that case, you find the refracted ray will bend away from the normal. You can write refracted ray will bend away from the normal. Here, if this is the denser medium and this is the rarer medium and this is the normal, then you find if this is the incident ray, this is the angle of incidence, here the refracted ray will bend away from the normal. That means this will be the path of the refracted ray and this will be the angle of refraction. That means here the refracted ray will bend away from the normal. You have to remember these two cases that are applied to a refracted ray. So this is all about the refraction of light and the laws of refraction and the refractive index and the two things that are applied to the refractive index or refracted ray. Thank you.